Okay, finishing up on homework from section 4.5b, U-substitution using definite intervals. So 81, we go through U-substitution, U value being 2x, 2/3 x. The derivative is simply 2/3, so dx simply 3/2 du. We make our substitution. 2x/3 gets replaced with u. Dx is replaced with 3/2 du. So no x's need to be canceled out, so pull the 3/2 in front. Integral of cosine is simply positive sine. We found the antiderivative. Now we have to evaluate this using our upper and lower bounds. But since we went through U-substitution, we have to also convert our lower bounds and upper bounds from in terms of this is right now in terms of x. We have to convert this into terms of u. So our assignment is u is 2/3 x. So 0, plug in for x. We get 2/3 times 0, which is 0. So our initial lower bound is 0, but it will remain a 0. Okay. Upper bound is initially pi over 2. Plug pi over 2 in for x. So we get 2/3 times pi over 2, which is pi over 3. Our old upper bound is pi over 2. And now our new upper bound is pi over 3. So now we're going to evaluate between our upper and lower bound. Pi over 3 goes first. So 3/2 sine of pi over 3. Lower bound goes next. So 3/2 sine of 0. So sine of pi over 3 is simply √3/2. Sine of 0 is simply 0. So we get 3√3/4 as the definite interval. Okay. The rest is using evaluating integral using properties of even and odd functions. So the definite integral of x squared from 0 to 2 is equal to 8/3. All right. Now what we have to be aware of is that x squared, y equals x squared, is an even function, right? If we have a parabola, y equals x squared, the graph is going to be symmetric about the y-axis. Okay. So for part A, it's saying find the definite integral from -2 to 0 of x squared. Well, we know that from 0 to 2 is 8/3, so from -2 to 0 must also be 8/3. Okay. For part B, the definite integral from -2 to 2 of x squared, we know that this is an even function. So if I know that this is 8/3, then if I'm looking for this, the same distance on the other side of the y-axis, then I can double this. So 8/3 times 2, or 8/3 plus 8/3 is simply 16/3. Okay, part C, the definite integral of 0 to 2 of negative x squared. So I can pull this negative out in front. So the definite integral from 0 to 2 of x squared, we know is 8/3. But if we pull a negative in front, we'll have to make that a negative 8/3. Okay, part D. Leading coefficient we can just pull in front. So the definite integral from -2 to 0, we know this region is 8/3. So this gets replaced with 8/3, but then coefficient times 3, so we get 3's cancel out, we get 8. Okay, last problem here, 106. Use symmetry of sine and cosine functions to evaluate the definite integral. Now recall that sine of x is an odd function. There's symmetry about the origin, and cosine of x is an even function, which has symmetry about the y-axis. Okay. So we know sine is an odd function. So if the bounds are the same distance away on either side of 0, then we know that the positive and negatives will cancel each other out, giving us 0. Okay. For part B, cosine we know is an even function. The bounds are same distance away from 0 on either side of the y-axis. So using properties, if we know this is an even function, then we can split this up into two smaller problems, right? We know that if we can find the definite integral from 0 to pi over 4, then really we know the other side will be doubled because it's an even function. So the definite integral for cosine of x, cosine becomes sine. We evaluate between upper and lower bound. So sine of pi over 4 minus sine of 0 is simply √2/2. So one side is √2/2, so the other side must also be √2/2. So we multiply by 2, we double it, we get square root of 2. Notice that we don't have to change the bounds here because we didn't go through U-substitution. Okay, so the bounds stays because we did not convert anything to be in terms of U. Alright, part C, again, cosine, even function. Our bounds are same distance on either side of 0 of the y-axis. So if I can find the definite integral from 0 to pi over 2, then I can just double that, and that will give me the same as the definite integral from negative pi over 2 to pi over 2. So the definite integral of cosine of x is simply sine of x, evaluate between upper and lower bounds, so plug pi over 2, and then plug in 0, so sine of pi over 2 is 1, minus 0, which is 1. So if we double 1, we get 2 times 1, which is 2. Okay, part D, definite integral from negative pi over 2 to pi over 2 of sine of x cosine of x. Now, we don't know exactly what this is. We don't know whether this is an even or an odd function. So we're going to go through our test. Okay, test whether our function is an even or odd function. So remember, if I can replace every x with negative x, and if I get back in return a negative version of the original function, then what I have is an odd function. So I'm going to replace every x with negative x, and sine of negative x is simply negative sine of x. Cosine of negative x is an even function, so that remains cosine x. So negative sine of x times cosine of x is negative sine x cosine x. So f of negative x does equal to negative f of x. So since this passes the test of an odd function, we know this is an odd function. If it's an odd function, then we know that if we're trying to find the definite integral from one bound to the next, with both bounds being the same distance away from 0, then we know that the positive and negative will cancel out, leaving us with 0.